On the right side of the equation, if I FOIL that, it would be 5x squared minus 25x plus 17x minus, somebody help me out. 85. Oops. 85. Add like terms would be 5x squared minus 8x minus 85. Now, if you like to box that, instead of doing this, instead of foiling it, you can put it in a box. 5x plus 17, x minus 5. 5x times x is 5x squared. 17 times x is 17x. 5x times negative 5 is negative 25x. And 17 times negative 5 is negative 85. Like terms, and we would get the same thing we got when we FOILed it. Okay, now that we have that, we're going to move everything to one side. So I'm going to take all of this over here on this side, and I'm going to move it over here. So I would subtract 5x squared from this side, which would give me x squared. Then I'm going to add 8x to both sides. Okay, so that would be negative 8x. And then I'm going to add 85 to both sides, which would be plus 15?
Yes.
Equals 0. That will leave me 0 over there on that side. What do you think I'm going to do with this trinomial? Factor. Factor. You're on the right track.
Yeah.
So what would that be?
Minus 30x minus 5.
X minus 3 and x minus 5? If I set both of those equal to 0, I'll get x equals 3 and x equals 5. Two different answers, which is fine. But let's go back up and look at what our excluded values are. What are our excluded values if I said that and that denominator equal to 0? 5. That's an excluded value. So that cannot be my answer. My answer must be x equals 3. Any questions? I'm not even sure. That is like problems, well, starting at 9. Right. Now I'll turn to page 546. We're going to do problem B. I'll give you a minute to write that in your notes. This is not a fraction equaling a fraction, so I cannot cross multiply. I'm adding. When I add, I must get a common denominator. So fraction plus fraction equals fraction. what would my common denominator be? I have to have all of this in my denominator. 2x minus 7, right? I covered the x minus 7 and the 2. 2x minus 7. 2x minus 7. What is missing here?
2.
The 2. So I'm going to multiply all of that by 2, which just means I distribute through. So 2 times 2x is 4x, and 2 times negative 9 is negative 18. What is missing here?
X minus 7.
X minus 7. X times x is
X
squared.
x squared, and x times negative 7 is
Negative 7x.
negative 7x. What's missing here? 2. 5 times 2 is 10. Now, the good thing about when you solve a rational equation is once you have a common denominator, you can ignore and mark out the denominator. It's gone. No more fractions on this problem. 4x minus 18, I'm just rewriting it, plus x squared minus 7x equals 10. That is a minus 18 right there. Oh, shoot. 4x minus 18. All right. Collect like terms. That will be x squared. You always want to put it in descending order. X squared. What's 4x minus 7x? Negative 3x. Minus 18 equals 10. What do you think I do next?
Move the 10 over.
Subtract the 10, move the 10 to the other side. X squared minus 3x minus 28 equals 0. I'm going to have to factor negative 28 to get my factors. I would do negative 28 and find all the factors of negative 28, which will be negative 28 and positive 1. Positive 28 and negative 1. What else? 14 and negative 2. Negative 14 and positive 2.
4 and 7.
7 and negative 4. Negative 7 and positive 4. That's it right there because I want it to be a negative 3. So x minus 7, x plus 4 equals 0. So what does x equal?
Negative 7.
X equals 7 and x equals negative 4. Let's go back to our original problem, which is right here. What are my excluded values?
7.
7 is an excluded value, so is 7 an answer?
No.
No. My answer is x equals negative 4. Any questions on that? All right, look on page 547. We're going to do a few story problems. Kelsey is kayaking on a river. She travels 5 miles upstream and 5 miles downstream in a total of 6 hours. In still water, Kelsey can travel at an average speed of 3 miles per hour. What is her average speed of the river's current? So we're looking for the river's current. If you go there to the bottom of the page where the table is, it will tell you almost exactly what to do. Okay, so we're going upstream, we're going downstream. It tells you to put distance here. average speed here and time. Now, distance, how far did Kelsey go? 5 miles up and 5 miles back, right? So upstream she went 5 miles, downstream she went 5 miles. She went the same distance, unless she got lost, which is possible. Her average speed. Now upstream, do you think it was harder or easier for her to go? Harder. So you're going to take her average speed and subtract the current from it because she's going against the current. And then to go downstream, she's going with the current.